All right, you guys, I'm trying to get this up and running, and every time I do this, it feels new. Okay, that's not what I want to do. Okay, I hope you can see this screen behind me here. I don't know why this won't go away. Unpin. Okay. All right, hopefully that does the trick. All righty. Okay, so this video is for those of you who are at home. I'm sorry, I'm looking over here. The cameras, the screen I'm looking at is there. I don't know if you're seeing me from which camera. I hope I'm looking at the camera right now, but it's over there, so I can't tell. Anyhow, okay, so today we're going to talk about definite integrals on the TI graphing calculators, okay? And there's the older variety of calculator and the newer one. I'm assuming most of you are more familiar with the newer one. But I'll show you how you can integrate on your calculator screen after you've created a graph. And you basically do second calc 7. So that will look like this. When you have a graph, you do second calc, and then it's option number 7 down there. Many of you do this. You click to get all the way down there to number 7. Some of you have realized it will roll over to get to number 7, but honestly, the quickest way to get to number 7, if you're here, is to just literally type the number 7. It's the fastest way. Please get in the habit of saving yourself time on your graphing calculator. Okay, if you don't need a graph at all, the limitations of this is if your window is not set up correctly, and you try to integrate, you often will get errors because it cannot integrate something that's not on the screen. So to avoid that at all, you can just do no graph needed at all. You can just literally type in, what is it, math 9, isn't it? Yeah, math 9. So you just do math 9. And so again, to get down there in one step, I'm just going to click the button 9 on my screen, on the calculator right here, number 9. Just click number 9 instead of going down using the down arrow. And then you can just type in whatever function you want to put in there. Okay, on an older calculator, the way that you do this is a little different. The syntax is a little strange. It's still math 9, so I go to math and then 9. But the syntax is confusing. You have to put in the integrand first, which is y1. So you can either use, the y equals y bars menu, and then you have to tell it with respect to what variable. So you would have to tell it, with respect to x, and then integrate from a to b. It will not do an indefinite integral. It can only do definite integrals. So anyhow, those are some options for you. For the sake of this video, so here, for instance, suppose you wanted to integrate from 2 to 3. You wanted 2x plus 5 dx on the older calculator. So you would do, here, clear, you would do math 9. And you would integrate. So you would tell it 2x plus 5 with respect to x, and I want to integrate it from 2 to 3. And then it would tell me that is indeed 10. Okay, I'm pretty sure almost all of you are going to prefer the new, or have the newer calculators, and you're going to prefer to do it this way. I'm going to integrate this from 2 to 3. And what am I integrating? 2x plus 5 with respect to x, and you get the same answer, 10. So obviously less awkward for typing it in. That's why they made this edition of the calculator. Okay. So one way to do it is after you've created a graph. And what I like about this is you can actually see what's going on. So once you've determined appropriate boundary values for a given function, so by boundary values, I mean the upper and lower limits, a and b, here are the basic steps for getting the calculator to approximate the area. I would recommend you enter the function in y1 and set an appropriate graphing window. We're going to do an example down here. Okay, graph the function, and then when you do second calc 7, integrate, it will do this for you, but it'll ask you for an upper and lower bound. And the default method for entering the upper and lower bounds is to use the arrow keys. I don't recommend doing that. I recommend you type the boundaries in directly, and I'll show you what I'm talking about. So here's an example of one. Let me go to the y equals button and just type this in as y1. So y1 is the opposite of the quantity x minus 2 squared plus 5. And so I want to set my graphing window from just eyeballing this thing in the x direction. I don't think I need to go all the way to -10. I can probably get away with going to like -2. And x max, I don't think this thing is going to get I don't think this y-intercept here is terribly far. I think probably 10 is perfectly good. Put one tick mark. Every single value of x seems great. I'm going to hit focus here. In the y direction, I really don't know how far down it goes, -5, and y max of 20 is probably good enough. So there I have my window. I'd rather look at that a little more up close. So when I do my window, I'm going to just go to 1, 2, 3, 4, 5 in the x direction. So I'll change this to a 5, and in the y direction, I don't need to go as high as 20. I'll try 10. And I don't think it's worth to go this much trouble when you're doing these on a test or something, but I do think it's valuable for the sake of this video. So there I have the window, okay? And so what it wants me to do is write an integral expression representing the area of this thing, which is the area under the curve. And so I'm going to integrate this thing from, well, I have to evaluate where this is. Okay, it tells me that area R is the area under the curve in the first quadrant. So that's important to pay attention to. Always when they use R, they use capital R all the time to represent a region on the AP test. Always make sure you read carefully what R is, because from somebody looking at this might assume this is also part of region R, and it is not. So they're telling you it's only the part in the first quadrant. So very important. So we're going to use our value of A is 0 here, and what we're interested in is this integral here. What is the area of this region here? Okay, well, where does it intersect here? When I look at the graph, it clearly doesn't have an intercept at an integer value, 1, 2, 3, 4, and change. So you guys know to do second calc, look for the 0. So second calc 0. And the left bound, you guys are typically do like this. You play with the calculator to get to the left edge of that. I would just tell it 1, 2, 3, 4. Just type in the number 4 in your calculator. For left bound, just type in a 4 and hit enter. Okay, and then when it wants the right bound, I could use the arrow keys to get over there and, go over here. But honestly, I think if I just type 5, I'm going to be fine. Just type 5. And then it always asks for a guess. And the thing is, I already told it it's between 4 and 5. So I let the calculator do the guessing. I just hit enter. Every now and then I'll get an error when I do that, in which case I just do it again and I give it an actual guess. And there it tells me. So I'm integrating from 0, because we're only in the first quadrant, to this number 4.236068. Now that is a tremendous amount of writing, and I don't want to rewrite that decimal every time. So one recommendation I have for you is, we'll call this B up here. What I recommend you do is you write this on your paper, and you can use it in the rest of your calculations. If you should have to write an integral on an AP test or something, you can do that. Okay, the problem is I want to get that number stored into the calculator's memory in place of variable B. So here's what I can do. Because I just calculated this value of X, I'm going to do second quit. And if I ask it for the value of X, you'll notice that is that number. Now, every time I graph something new, I may lose that value of X. It uses the memory location X for a lot of different things on the calculator. So what I'm going to do is I'm going to store that into the calculator's memory. So down here at the bottom of the screen, bottom of the calculator, it says store. And when I hit that, it's asking me for store what? Oh dear, I want to stay in the call. Yeah, no one's here, so it thinks it's just me. So I'm going to do answer, and I'm going to store that into alpha. So I'm going to hit the alpha key. So I'm going to do alpha and then B, which is right there. So I'm going to do alpha B. And so now, anytime I use B, if I do alpha B now, anytime I use it, it will put all of those decimal places in there. It's a lot easier than typing 4.236. If I just type in alpha B, it will do the same thing. So now I have that value locked in there. So what I'm going to do now is I'm going to go and integrate this thing from A0 to B, 4.236068. And I need to type this in correctly. Please be careful how you type this on how you write this on a test or something like that, or a homework. Okay, that's the integrand, but this is the height of a single rectangle. And the problem is, if you add up an infinite number of heights, you're going to get an infinitely large number. So the only way this actually makes sense is to multiply it by dx, the width of one of these rectangles. The problem with what I've just written here is this violates the rule. The rules of algebra say, oh, PEMDAS, you'd only multiply the 5 by dx. And so it's important that you actually do this with your expression, that you put the integrand in parentheses in this context, because that plus 5 times dx would mean you're only going to multiply the 5 by dx. I don't know how fussy the AP test graders are, but I'm very fussy about that. Please don't mess that up. That's a 1-point notation error every single time. Okay, so there's the integral representing the area. And then it said find the area of r accurate to 3 decimal places. So now what I'm going to do is I'm going to use this. Notice that I've already put this into the calculator memory, so I don't want to type it in again. So what I'm going to do is I'm going to do math 9, and I'm going to integrate from 0 up to b. So I'm going to do alpha b. That's a lot less typing than what I had before. Okay, and then vars, to get y1 in there, I don't want to retype it. I'm going to go to the vars menu, and I want y vars, and I want function, and I want y1. And so it knows to substitute in y1 for you. I'm going to integrate with respect to x. Okay, and there I have it. I find the area of region R accurate to 3 decimal places, and here we are, 14.78689326. Now this is too much writing; it's unnecessary. On AP tests, they will let you truncate. You could truncate here. If you write 14.786, you get credit, but I want you to develop good habits. So on homeworks, I do expect you to actually round. I don't want you to forget that important skill of rounding. So I would say 14.787. Okay, I don't need to say square units. It might be nice to write square units, but because there are no units or dimensions of any sort here, there's no need to write down any units. And frankly, on a test, if it didn't give you units, I wouldn't write anything down, because they might be looking at units and then you lose a point because you put the wrong units on there. So I'd probably leave it like that. For homework, give this. For a test, you could give that, or as many digits as you like, but you're wasting time if you're writing down more than 3 decimals at this point. Okay. All right. Next question. This time we have the graphs of 2 different functions here. One of them is obviously exponential. So since I called this y1, I'm going to let this remain graph y1, and I'm going to have this be graph y2. So this will become y sub 2. That's my second graph. And then what it says is find the coordinates of the points of intersection of the graphs accurate to 3 decimal places. So the first thing I have to do is decide this point here and this point here. Okay, so I have to be careful with this. Oftentimes on the AP test, they use capital P to represent this point here and Q to represent this point here. They often do that, and so I'll use that with you. But what I need to do is I need to write down the coordinates of things. So I'm going to call this point here the coordinate A comma B, and that's now I'm switching what B is. Remember, B used to be up here, the y-intercept. So I'm going to redefine for this problem what I mean by that. Point A and then point Q, point Q is going to be, okay, notice how when I use these rubber erasers, it smudges really badly. I know the SAT is going digital soon. This is why I have you use those white erasers when you erase. This smudging would destroy 2 or 3 answers on a multiple choice Scantron, and that you don't want that to happen on your tests. Okay, I'll call this AB, and then I'll call this C and D. Okay, and then one slight confusion that comes in here is I'm using C to represent the coordinate of this, and that might be in conflict with when I just use an arbitrary constant of integration. So you have to be careful about how you choose things. You could also use X sub P, Y sub P, and so on. The problem with doing that is your calculator doesn't have subscripts for memory. So you have to just be flexible with how you manage things. So first things first, find the coordinates of intersection here. So what I'm going to do is I'm going to do y2 is equal to 4 times 1.2 raised to the negative 2x power. So there, that'll be the red graph on here. Always double check that you type things in correctly. And we're gonna graph that as well. And now I have the red graph coming in there, and there they are. Wow, it's really slow. The delta x that's programmed into this calculator is rather slow. So I'm going to define P as point A here, the x coordinate of this first point of intersection. So I go to second calc intersect. That's choice 5. So hit 5 on the keyboard. Okay, the first curve is the blue curve, hit enter. The second curve, it gives you its equation up here, is red, hit enter. And then it asks you for a guess. So I'm going to guess based on this graph 0.5. And there it is. It's telling my first point of intersection is 0.64440274, comma, and then I want to get the y coordinate of that, which I'm calling b here. Okay, it's this number down here. Y equals 3.1623561. Okay, the thing is, I'd like to capture those numbers in the calculator's memory. So what I can do is I can right now do second quit. If I just type variable x, it's going to give me that 0.644. I'm going to store that into alpha A. So I now have A in here as 0.644. Okay, now how do I get B? Well, it's variable y. If I go to variable y, where's alpha y? Oh dear, how do I get alpha y down? Oh, there it is, down here, alpha y. If I get that number, you'll notice that's by 3.16. I'm going to store that into alpha B. So store that into alpha B. Okay, this will overwrite the old value of B that I had there in the last problem. I'm keeping track here to write this down carefully. It will overwrite the old value of B. So whatever used to be in B is now gone, and this is the new value. Okay, and then point Q, all right, we said is coordinates C and D. So I'll write those down, and I will store them into memory. So let's go back to the graph, and let's go back to this graph. Whoops, I'm sorry. Back to the graph. There it is. And I'm going to do second calc intersect again. So hit the 5. And the first curve is still a blue curve. And the second curve is still a red curve. Okay, but this time it wants a guess. I'm going to tell it 1, 2, 3, 4. So I'm going to tell it a guess of 4. Don't waste time doing this. It'll take forever to get there. Just enter the number 4. And it'll take it and hit enter. And it'll go right in. So there it is. So now I have the x coordinate is 4.0189432, and the y value is 0.9238685. Okay, I want to make sure that I get those into the calculator's memory. So immediately second quit. Okay, I want to look at x, and you guys, I really don't need to look at x. I can store it into alpha C, and it will tell me the value that it put in there. So I know I got C into memory. And then to get the y value, I'm just going to do alpha y and store that into alpha D. And it'll tell me again the 0.92 number. And what it's saying is, okay, that is indeed the value of D. So for now on, if I ever want to use the value C or whatever, it will have that number stored in memory. Okay, the question did ask earlier for 3 decimal places, and so this is just more to show you guys what I was doing with the calculator. If I were writing this down, I would say point P has coordinates 0.644. That's 3 decimal places. 3.162, and point Q is 4.019. This, if I chop here, that 9 tells this to become 0.019, and I want you to do that on homework. I want you to learn good habits. On test day, you can truncate, and I will accept it. But I don't. When you go on to engineering or scientific, physics, anything like that, I want you to get in good habits and get accustomed to rounding. And this would be 0.924. And so there, I've answered the prompt, but I have all the accuracy up here that I could possibly need. Okay, now it says to write an integral expression representing the area of S. So S is just this region here. Okay, and so you guys, I maybe skipped a step here when I was doing this earlier problem. What we're really doing is we're always using the element of area. dA is an infinitesimally small contribution of area. This dA represents the area of just one rectangle. And that's always a base times a height in every case. It's always a base times a height. So for us, what's the base of this thing? Well, that little width there is called dx. And the height was this height right here, f of x. And so what we're saying is we have this infinitesimally small contribution of area, and that the area formula is base times height. We normally don't write it dx times f of x. There's nothing wrong with doing that. Everybody always puts f of x dx They always put this first and not second. Okay, and then what's happening is we're integrating both sides of this thing. So essentially, we're saying if you integrate an infinite number of infinitesimally small contributions of area, you will actually end up with the area equal to the integral of f of x times dx. That's basically what's going on there. So what's going on in this problem? Well, now when I set up a single rectangle here, the height of it is not equal to f of x. It's the difference between those two. So what I'm going to have to do is you don't have to write this down, but in terms of my thinking, this little contribution of area, that area right there is referred to as dA, a little differential of a little tiny contribution of area is equal to the base times the height. And that's just one of them. But how many such rectangles could I draw? An infinite number. So what I want to do is I want to integrate both sides of this, and that gives me the area is the integral of the base, which is still the same thickness, dx, but times the height, which is the difference between these two things. So it's awkward to write dx and then times something else. I'm going to put my height first, times dx. And you have to do the top one minus the bottom one. You have to pay attention to that. Please don't use calculator notation. It's fine for you to do this to keep yourself organized, but please don't write y1 minus y2 in your work. They don't accept calculator notation. So I suppose you could. I suppose technically you are using legitimate notation by saying y1 and y2, but just to avoid confusion, the one on top is f of x. So I would just write f of x minus the bottom one is g of x. And so what this is saying is the area of this entire region is the sum of all these rectangles who have a height of this minus this and a width or a base of that little distance there, dx. Okay, if I've defined what f of x are and what g of x are, this is a perfectly good answer. Okay, problem is I didn't put my bounds of integration on here, so I need to put those on here. So fortunately for me, I've defined them up here. And remember, we said point Q had an x coordinate of A, and point P had an x coordinate of A, and point Q had an x coordinate of C. Okay, and because I clearly defined those down here, a competent algebra student could substitute those in here. Now, they wouldn't be able to do the actual calculus, but it isn't asking us for that. It just says write an integral expression representing the area of this region S. Okay, and now it is saying to evaluate it. So I'm not really done doing this. I have to actually go ahead and calculate it. Okay, I recommend you do this on a test as opposed to actually writing it out, because one issue that comes up is, well, how many decimals do you need? Maybe having 3 decimal places down here will work, but maybe not. Maybe you need a few more. So how do you know how far to go? So rather than do it this way, I'd recommend you leave it in this form and just pop that in your calculator, just knowing when you do it in your calculator, you'll do y1 minus y2. But if for those of you who really want to see the numbers, you want to see everything written out, I'm going to have to go from A to C. So I'm going to go to 4.0189, and I'm going to integrate f of x, which we had here, negative x minus 2 squared plus 5 minus g of x, 4 times 1.2 to the negative 2x, close parentheses, and then dx. So this is typically what a person would write on their paper on an AP test or whatever. It's a lot of writing, and it's a real pain to enter that into a calculator. So I'd recommend you get accustomed to managing things like this. This is perfectly acceptable. So I'm going to do Math 9, and I'm going to go from A to C of f of x, which we decided was y1. Somewhere if I do alpha y equals on this thing, whoop, that's not it. Alpha, which one is it? Somebody's shown me this on here. Alpha table set? No. Alpha zoom? No. Alpha trace? There it is. So if you do alpha trace, you can choose y1 right there off of that menu. That's another way of getting to it. And then minus, the way I'm accustomed to doing it is hitting this vars menu right there. I'm accustomed to hitting the vars menu and going into yvars function y2. And there we are. The calculator will sub that in for us. And then I put dx here, and now it's going to work it out. And it gets me the area of 7.16032. And so if I round this, 7.16032 7.60 is a good answer. If you write 7.16, I do believe on the AP test they would give you full credit, but I'm not 100% certain about that. Because if you write 7.16, that might indicate that you only rounded to 2 decimal places. And so I'm not certain. I'm pretty confident you'd be okay there. I would actually just write it out like this so that you're set. Okay. All righty, guys. I will see you at the next video. Okay. All righty. Okay. Bye-bye.